So 8.1 day 2. So we have special triangles. The special right triangles are 30, 60, 90 and a 45, 45, 90 triangle. They have ratios. You see 2 triangles here, and I'm going to show you 2 ratios for them. Actually, I'm going to skip down to the 30, 60, 90. We're going to do it first, and then we're going to come up to the 45, 45, 91. Just because I think it's easier. Okay, so when I give you these, I'm giving you the ratio with the scalar. A scalar is like the scale factor. So it could be 5 times larger, half as large. Got it? So every 30, 60, 90 triangle has these ratios. So across from the 30 degrees. So put your pencil, whatever, on there, finger, and go across. What side do you hit? That one, right? That ratio is X. Okay, so that's the scale factor. When I talk about this, I will say 1 because that is 1x. Okay? Across from the 60, so across from the 60, put you where? There. It is x square root of 3. Now, we've learned the shortest side is across from the smallest angle, yes? So I've said this is 1, and if x is 1, that makes this just square root of 3, correct? Is square root of 3 bigger than 1? Yeah. Yes. We don't know what it is, but we know it's bigger than 1, don't we? Mm-hmm. Okay. So now across from the 90-degree angle, so across from the 90-degree angle is what part of the right triangle? The hypotenuse is 2x. So when I draw these on my piece of paper, because if you need this on your test, this is what you do. You write 30-60-90, and you write 1 square root of 3 and 2. And what goes with all of them? An x, right? Okay. So if you remember 1 square root of 3 is 2, 30, 60, 90, 1 square root of 3, 2 is 1 smaller than the square root of 3. Is square root of 3 smaller than 2? Because the square root of 4 is 2, correct? So do they go across from where they're at? Okay. So that's the 30, 60, 90, and I will show you how to use them. I just want to show you the ratios right now. Okay? Now we're going to go up to the 45, 45, 90. If you look in your book, I'm going to give you the first one that they will tell you, and then I'm going to give you the one I want you to remember. Okay? First one we're going to write over here because the one I want you to remember is going to be right here. Got it? So they say across from 45 is x. So that means across from the other 45 is a what? X. And across from the 90 is x squared of 2. Now, I'm going to change this because if I wrote it this way, it'd be 45, 45, 90. Don't forget your degree symbols. It'd be 1, 1, square root of 2. Yes? And if I'm trying to remember 45, 45, 90 is 1, 1, square root of 2, and I'm trying to remember that 30, 60, 90 is 1, square root of 3, 2, is that going to be kind of confusing? Mm-hmm. Okay, because the 90s aren't the same, are they? Because I have square root of 2 here, and I have 2 here. Would it be helpful if the 90s were the same? Mm-hmm. Okay, so how could we make the square root of 2 just 2? What would I multiply it by? Itself. So square root of 2? So if I multiplied the square root of 2, if I multiplied this by the square root of 2, then I have to multiply what? All of them? Mm-hmm. So it changes my ratios to x square root of 2, x square root of 2, and 2x. So these are the ones we're going to use. So I'll write it. I'm going to just write it under. I don't know why I didn't write the 30, 60, 90 under there. So we have square root of 2, square root of 2, and 2. Okay, these work. These work. Not that they don't work. I'm not going to force you. I personally switch back and forth depending on which one I am given. But I've been doing this a lot longer than you, right? And I want to give you the best one I think. I think this is the best one to remember. Okay? So I got 45, and see how this is across from. So 45, 45, 90, square root of 2, square root of 2, 2. Is square root of 2 smaller than 2?
Mm-hmm.
Yeah, definitely, right? Okay. 30, 60, 90, what were they? 1, square root of 3, and 2. And what's with all of them? There's always a what? X? If you want to put the X there, put the X there. You don't want to put the X there, don't put the X there. But don't forget it's there. The X is a scalar. So I could multiply any of those by 6, 10, 1/2, 37, 1800. Got me? And when we do the sine, the cosine, and tangent, which we will work our way to, you get those ratios because they are fractions and the x's reduce out. That's what you get down to. Okay? So now let's use it. So we'll go up here. So what you do, the first thing you do is anytime you have a picture or you draw your triangle and label it. So this is 7. What angle is 7 across from? 45. What's the ratio for 45? X squared root of 2. So 7 equals x square root of 2. Yeah, because that's what I just told you, didn't I? It's 45. It equals here. I'll put the x's there. Put the x's there so you guys don't forget them. I have a feeling that you're already forgetting their x's. And that's multiplication, yes? Okay, so across from this, 45 is what? 7. It is x squared root of 2, but we know it's 7 because aren't both sides the same?
Yeah.
Okay. What is the ratio across from 90? 2x. So all I need to find is what, and then I'll be able to find this side. X. So do I have an equation that can help me find x?
Mm-hmm.
Yes. So I have x squared root of 2 equals 7. Well, how do I solve that equation?
I mean, we have to multiply the square root of 2 by itself.
Not yet. We don't have to yet. Don't have to move it over to the other side. And what math did I just remind you this was? Multiplication. So I need to do what? No. Divide. So divide by the square root of 2. Divide by the square root of 2. So I have x. These reduce out, right? 7 over the square root of 2. Now, Tristan, we have to multiply by the square root of 2.
Okay.
Why do I have to multiply by the square root of 2 now?
Because the square root can't be on the denominator.
Right. So square root of 2. Square root of 2. So that gives me 7 square root of 2 over 2. So this side right here equals 7 square root of 2 over 2. So the side you know, you're going to set it equal to its ratio and find x. Once I find x, can I just plug it into all the others?
Mm-hmm.
Yes. Your first thing, label, find x, plug in. Label, find x, plug in. Okay, so next example. What do I got?
Okay, so we know
Okay.
that the hypotenuse
Yes.
is 14.
And the ratio for the hypotenuse is 2x. So 14 equals 2x.
Okay, so will x just be 7?
Yes,
Okay.
but yeah. But they won't always be that easy. But yes.
Alright.
Okay, so what are my other ratios?
X square root of 2 for the
Couple
both
things.
45s.
Upward bound presentation will be in the auditorium. That's for all 8th graders during IEP today.
So I have 2x equals 14 Divide by 2, and x
Also,
is
grad members.
7
The
7.
meeting in the media
So
center
these
for
sides
junior high,
equals
during
7.
junior high IAC. I'll do
Equals
senior high
7
during senior high IAC.
Square root of 2.
That'd be for rad.
Am I making sense what we're doing here,
And that's
guys?
for down hesitation 8th graders.
So do you see why those ratios are so important?
You will meet in the auditorium during.
And to
IAC.
write those on the top of your test should take you about 2 seconds, shouldn't it? So work on knowing them. Okay, find the missing parts of the next. Well, what kind of a triangle do I have?
Right.
Yes, a right. What special triangle do I have? What are the measures?
It's the 30, 60, 90.
So my ratios of a 30, 60, 90 are x, x squared of 3, and 2.
2x.
Yes, 2x. I said x is on the other and I didn't know that one. Thank you, Tristan. Okay, so first thing, what do?
Okay, so we know the hypotenuse is 10 feet, which is also 2x.
So I label, so 2x.
And then the 30 is
X.
x, and then the 60 is x squared root of 3.
Okay. Now, I will tell you, I personally always label what I have first, but I can tell you, I know kids that go, nope, the ratio is x, x squared of 3, and 2x. And guess which way they label it? X, x squared of 3, and 2x. In that order every single time. They do 30, 60, 90. When they do the 45, they do the 45, 45, and then the 90. Because they remember it that way, and that's the way they're going to write it. Does it matter how you do it? Nope, as long as you get it right. So which one am I going to solve?
The other one.
Do I need to work that out, or can you all tell me it's 5?
It's fine.
Are all good with 5? So x is 5. So now I just what? Plug it in. So it's 5. No, it's just 5. X is so
X is 5.
x is 5. So let me write it as x equals 5. I kind of wrote it. So x equals 5, and x squared of 3.
It's 5 square root of 3.
X squared of 3 equals 5 squared of 3. We found x, we plug in. We labeled, we solved for x, and we plugged in. You guys want to try this one on your own?
Yeah.
Okay, try it. I don't know why I keep moving my paper.
I feel confident in that. Yep.
Oh, we were wrong on the other ones. We forgot. One of them we forgot labels. No, we did not forget. Oh, yes, we did. We forgot labels on the first one. Shouldn't they all have feet next to them?
Oh, yeah.
Because they gave you a label, they should have a label. This is 10 feet. Okay, did you get 28 square root of 3 over 3 is your x?
Yeah. I got 28 square root of 3. Yeah.
Over 3. Okay, if you have 28, I kind of skipped to my answer because I rationalized in my head by now. If you have that, is it wrong?
It's just
It's not wrong, but is it?
not fully.
It's not right either, right? So we have to multiply by the square root of 3 and the square root of 3. And my brain kept wanting to reduce 28 and 3. It's like 3 should go into 28. Well, not evenly, right? Okay, Questions? Please ask if you didn't get it right.
I know what I did wrong.
What'd you do wrong?
I put them in the wrong spot.
Oh.
I was wrong. Sorry.
Okay, you gotta get them labeled right, right?
It's because the 28 and the 30 are supposed to get I just mixed up those two.
Oh, okay.
But I see what I did.
Okay.
How did you get 56 square root of 3 over 3 equals 2x?
Because you plug this in for x. You plug this
Oh, okay. I see.
in the 28 square root of 3 over 3 in for x. So 2 times 28 is 56.
Okay, I see. I'm
Okay,
not-
any other questions? These are the questions you should ask. You three all good? Tori, ask me, please.
Well, I don't know how to do them.
What don't you know how to do? There's 3 parts. Label, solve for x, plug
I
in.
can label it. I just don't know how to do the rest of it.
Okay, so you get labeled.
Yeah.
So once you labeled it, so you have 28 equals x squared of 3.
Yeah.
Okay, so this is multiplication, so I have to divide by the square root of 3. So you get 28 over the square root of 3. Okay, and I can't leave that square root of 3 on the denominator. So I gotta multiply square root of 3 over square root of 3, which is just 1 if I would reduce it, or correct? So it doesn't change it, it just makes it look different. So I have 28 square root of 3, and the square root of 3 times the square root of 3 is 3. So this is x. So now all I do, this is x, so it equals 28 square root of 3 over 3. And this side is 2x, so you take 2 times 28 square root of 3 over 3, which equals 56 square root of 3 over 3. Does that make more sense?
Yeah.
So you label and you have that, solve for x, then plug back in for x. That's it. Every time. Sometimes it's going to be a whole number, sometimes it is not. It was a whole number, it was 5 here, correct? And now it's not. Just because it looks funny, you still have to deal with it. Like, we look funny and we have to deal with ourselves every day, right? I said we, not just you. Okay, so let's do some more. We got a whole nother page of notes in there, right? Just one?
Look, there's no more.
Okay, so first thing we're going to do is label them. I want to label every single one first. Can we do that? Okay, so we turn the page, and I don't have my ratios anymore. I think we need to write them at the top of your page. You got room to write them at the top of your page?
Yeah.
Okay, or a little bit, or somewhere on there?
Right here.
Side of your page?
Yeah.
Okay, do you want to try to write them on your own without looking before I say them?
Yeah.
Yeah? Okay, try. Without looking before I say them. Trying to steal my car.
For sure.
Xander, can you give me the ratios for 30, 60, 90?
I don't have anything.
Can you get the 45, 45, 90? No. Colton, can you do one? Just try.
30, 60, 90 is 1x, x, so square root of 3, and then 2x.
Good job. I will only correct you on this. It's x square root of 3. You said 2 the square root of 3. That would be an exponent.
Yeah.
Correct. So, but you're good. Okay? Caroline, can you do 45? 45, 90?
1, 42.
Okay, so 1, 1, 1 square root of 2. What's the other one I want us to try to use? Somebody else got it? Because that's not the one we were just using.
X square root of 2, x square root of 2, 2x.
X square root of 2, x square root of 2,
And 2x.
2x. Now, do you have to use one over the other? No. If you're struggling, this is the one I'm going to do because the 90s match. Remember? But if you guys look at it, if I'm given the hypotenuse, is this the one I want to use? Because I'm just dividing by 2, right? But if I'm given a leg, maybe I want to use this one. Why?
You just have x.
Because you just have x. So if you can remember both, is that to your advantage? Yeah. But if you're only remembering one of them, the one I'm going to keep repeating is this. But Caroline, you will get the same answer if you use the one you gave me.
I had both written down.
Oh, okay. Okay. So, do you guys see where, like, the benefits of both of them?
Yeah.
Because it will save you time if you use the top one for the leg, the bottom one if they give you a hypotenuse. But if you only are worried about remembering at this point, you want to remember the one that's going to be the easiest to remember. And I think it's this one because it's the 2x and the 2x on the 90. Okay. So, how about I can fit 4 at a time, I think. Yes? How about we just label them? Just label those 4. Oh, shoot. Okay, they're all 45s. I thought they were mixed up, but they aren't. Okay, just label those 4. Don't try to solve them. Just label them for them right now.
X4, 30, 60, 90s.
Okay, did the X's and Y's and S and U or Y and U, did that throw you off at all?
I just thought it was kind of weird that like x squared of 2 equals y. I mean, that just.
I just cover it up. They'll do that on like the worksheets. So they'll say Y equals or U equals. As long as I know what side is what, I'm good. Like we've been writing them right next to the side. I'm good with that. Got it? I just tend, because we find the X, it's kind of weird to have an X and a Y that you're trying to find. That throws me off. So I just kind of I just disregard their labels. Did everyone get them labeled correctly? Okay. So this first one might be a doozy to do, huh? Well, let's see.
Well, I just made that x.
Okay. If you did, that's fine. But if you did, that's great because it works that way. But I'm going to do it this way just so you guys can see it. So I have x square root of 2 equals 3 square root of 2 over 2. Yes? So I'm dividing by the square root of 2. That means I'm multiplying by 1 over the square root of 2. Correct? On the other side? I'm dividing by the square root of 2 because you have to multiply by the reciprocal, right? I'm dividing by the square root of 2, so it means I'm multiplying by 1 over the square root of 2 because they're fractions, right? Here, the square roots reduce. Look what's going to happen on the other side. Did the square roots reduce again?
Yeah, because then it'd be 3 square root of 2 over 2 square root of 2.
And the square root of 2 is reduced, so my answer is
3 over 2.
3 over 2. Okay, so do we know that Y, the top one? If we know this side, do we know the other leg? Yeah, so we don't have to do any math. I just wanted to get the label. So that is 3 square root of 2 over 2. And now here, I have to take 2 times 3 over 2, which is just going to be 3. Why is 2 times 3 over 2 just 3? Anybody? Because you're all looking at me like you don't believe me.
Please.
Okay.
So then if you labeled it the other way, how would it look different? Like,
Your answers should be exactly the same.
right, but how would it
Isn't it
look?
because the 2's
Because it'd be,
Yes. What?
crossing?
Yes.
because it
It is.
would be, x squared of 2.
Yes, if so, let me grab another piece of paper so I'm not writing on here. Okay, so if you chose to label this the other way, so this is 3 square root of 2 over 2. So if you labeled this x, x, and then x square root of 2, okay? So this would obviously be 3 square root of 2 over 2. And then here we have x, which is 3 square root of 2 over 2 times the square root of 2. Well, what's the square root of 2 times the square root of 2?
2.
Okay, so I have 3 times 2 over 2.
Oh,
So I get 3.
okay.
So either one of those ratios you use, should you get the exact same answer?
Yes.
Yes. I love when people get different answer and they're like, but I did it a different way. Okay, if the way you did is right, should you get the same answer?
Right.
Yes.
I knew the answer was going to be the same.
Yeah.
I just didn't know how to set up the problem
Yep.
if it looked good.
Yep. And I think reducing the square root of 2 sometimes is easier than multiplying by it. Sometimes our brains will go 4 instead of the square root of 4, which is 2.
Quick question.
Yes.
So, has someone ever like done it a completely different way but got the same answer, like without doing the way we just did it?
There isn't any other way you would do it unless they like did so much wrong that it happened to get the right answer. Like those are the 2 ways you can do it. Does that make sense? There are some problems like in algebra 2, the problem up on the board we're doing, and I've now shown them like 4 different ways to do it. You're essentially doing it the same way every time, but you're looking at the problem a little bit differently. And they're like, that's a whole different way. Well, it's actually not. I just factored before I multiplied, or I didn't find common denominators, I just reduced. So it's when you do problems different ways, you're essentially doing the same math, sometimes in a different order. Or you're doing it, you're changing it into one thing to change it back to the other. But essentially it's the same math, you just approaches it a little bit different. So, like when we set up the ratios, I could set up every problem 3 different ways, but you were still doing the same math in all 3 ways. Okay, so the next one, do we have it easy this time?
Yes.
Yes, because 2x equals 5, so x equals
2,
5
over 2.
over 2.
5 over 2. So all I have to do is plug that in. So if x is 5 over 2, so x square root of 2 equals 5 square root of 2 over 2.
It's weird how you just put one number and then you just add it on, and that's the answer.
Well, when you're multiplying and you can't, they're not like terms, it's really not going to change it. It's like when I multiply x and y, it's just xy.
Right.
So if they were like terms, we'd have to do a little bit more work. Like here, we had the square root of 2 and the square root of 2, so we had to do 2, and then, so if they're alike, we have to do more. If they're not alike, you just kind of put them there. Do you want to try the next 2 on your own? I think you should try. I'll start them after a minute. Ooh, this 3 is going to be fun. Just remember, when you are dividing, you're multiplying by the reciprocal. You're going to need that on 3, aren't you? There's hand sanitizer right there. Even smells good. Smell it. Smells good, doesn't it? What? Are you good on this?
Yeah.
Okay. Okay, how did 3 go?
I got 6 over 5 squared.
Okay, did you get x to be square root of 6 over 4?
Yes.
We're good there?
Yes.
Okay, so when you plug that in, we have 6 square root of 6 times the square root of 2.
Yeah, I
Over
got
4?
that. It was, yeah, and then it was just the getting it, like breaking it.
Right. And 6 is what times what? 2 times 3. So if I have a 2 and a 2, I can bring out a 2 and square root of 3 over 4. And then can my 2 and my 4 reduce?
Yeah.
Yes. So square root of 3 over 2. Are these going to take a minute to get used to moving them around and simplifying them? Yes. We'll work on that. We're going to keep on working that. Why do you think I tortured you last week? Now do you know why? Okay, how did 4 go?
Perfect. I think.
Perfect on that one?
Yeah.
See, and I would have thought this one was harder.
Well, I set it up different. I used the
X's.
other way. So then I just had 6 square root 2 and then just reduced. And that was all I had to do.
And this one, actually, if you set it up that way with the square root of 2, with the other way, it works easier too. Because if you have you'd have x square root of 2 immediately, and you would do this right away. And then you would be able to plug it in. So, or you divide by the square root of 2 and you have the square root of 3 in the numerator. So, questions on those before we do the 30, 60, 90s? Okay, so label your 30, 60, 90s. We're going to do it the same way. We're going to label them and then we'll do a couple together. Okay, did everyone get them labeled right? Tori, did you get them labeled right?
Yeah.
Okay. So, the first one. Well, we're going to be using the hypotenuse, correct?
Mhm.
So, divide by 2. So, x is 9 over 2. I don't know why I said 9.2. Because in my brain I was like, do not tell me your decimals. And so I gave a decimal. Okay. So what does that make x up here? 9 over 2. And then, well, plug 9 over 2 in here, and I get 9 square root of 3 over 2.
I really want to reduce that
What?
one. I really want to reduce that one.
Oh, because the 9 and the 3. Okay, so the next one, we have x equals 3 halves. That's amazing, correct? So what's that make my hypotenuse? I think it makes it 3. Yes?
Yeah.
Okay. And I can't reduce this one. My 60, can I? So it's 3 square root of 3 over 2.
Yeah.
Okay, so you got 2 on the bottom. It's really easy.
I know there's a RAD meeting in the media center during IEP today. Please report to your IEP first and then report to the RAD meeting.
Oh, you're asking. Okay, did you guys get X was what? 2 square root of 2? Did you guys see how I made that really easy?
Yep.
Because since they're in the square roots, I can reduce the 6 and the 3, can't I? So it reduces that 6 to a 2 and the square root of 1's 1. Yeah. So it's just 2 square root of 2. You thought it was going to be really hard, didn't you? You were going to multiply like by the square root of 2. Yeah, I know. And then you plug it in, so I get 4 square root of 2 and what? 2 square root of 2? And over here, finding my x just was square root of 3 over 2, wasn't it?
Yeah.
And so over here, square root of 3 over 2, and then square root of 3 times the square root of 3 is 3. So it's 3 halves. So even though they look a little hard, are they always going to be?